Hi everyone. In this video, I am going to walk through the shortcode for my trucking startup web applications. In this video, I will explain the main features of the app, how the code is structured, two major feature updates that we added, sorting and searching for loads. And we'll also explain how we use design patterns in the project implementations, like the builder, adapter, bridge, strategies, and singleton patterns in a practical way. I'll assume that you are comfortable with Java and Spring Boot, but maybe not super familiar with design pattern yet. So I will keep the explanation friendly and concrete as if we are pair programming. Let's start with a quick look at what the app does, and then we will dive into the code later. We have already seen the loads and invoice dashboard in the previous video from Project 4. So in this video, I will be mainly showing the two newly implemented features, the load sortings and the load searching. So for load searching, so at the top, we have a search bar where we can search loads by IDs, customer name, or status. So if I search for a customer name like um, by hitting the search button, we will be redirected into a search result page showing just the loads that match with this customer name. Now back to loads and let's try another one with load status. So here's all the load result with status deliver. Moving on to the second features, here the sorting toolbar. We can sort drug loads by customer name, rate, amount, pickup date, or delivery date. So when I click on customer name, so the loads will be reordered based on customer name in alphabetical order. Now let's pick rate up. So now the loads are reordered based on the sorting category that I just picked uh, from for the rate amount from the least to the highest. Same go for rate down, pickup date or delivery date. That is our sorting features. This sort features is implemented using strategy patterns, and we will go through the shortcode for this later in the video. Now that you already seen the UI, let's look at how the code is organized. I would go over the high-level architecture first before going into the code review of the two feature updates and design patterns. The project follow a typical Spring Boot layering. We have domain packet, the domain model containing core classes like load and load builder. Then we have persistent bucket. This bucket include JPA entities and repositories. Some entities are document, invoice, load, notification, and payment, along with their corresponding repositories. Then we have service packet. This include the business logics like log service, invoice service, payment service, and notification service. And inside service, we have the sort packet. This packet used to store sorting strategies for load. And we have web. This packet contains controllers and view models like load controller, invoice controller, source controller, load row, etc. Um, then we have billing. This package is for payment and tax related classes. Um, then and notify. This is for notification and channels. We also have tests using JUnit and Mockito under the source test Java package and UML class diagrams. These describing the class design. So the ideas of the projects is the controllers handle HTTP requests and prepare data for the views. Um, Servers implement use cases like create load, search load, pay invoice. For the repositories, they talk to the database via Spring Data JPA, and then domain classes represent the core concept like load. So let's start with the load domain and its design patterns, then build upwards. So load is our main domain objects, and we use the builder design patterns to create load objects. So as you can see, the load constructor already have a lot of parameters. If we try to construct this directly using the usual new load commands, it would be very easy to mix up the parameter orders and we easily forget what each argument means or leave out important fields if we keep adding more fields later. So the builder patterns solve these problems by letting us set properties one by one with meaningful method names, and then we can call create load method at the end. So it's like filling out a form step by step instead of passing lots of value into one huge constructor call. So here's our load builders. The load builder keeps all the same fields at load. Um, but they are temporary fields used during the constructions, and we have set a method. We have set a method to set field, and these setters return this. So we can change calls to them. And finally, we have create load methods to create the actual load. Let's see how it is used in the controller. In the load controller, when we want to add or create a new load, we can use the load builder here. You can see that when creating a new load using the load builder, we know what we are setting just by reading the method names, and you don't have to remember the order of the constructor parameters and the required fields like IDs. They are checked in one place. It is in the load builder creates load. This is why we use the builder for load, since load has many fields and which leads to a long constructor and it would be very error prone. So the builder patterns helps us with safe object construction, and we also want a readable and self-documenting code when creating loads. Next is the strategy patterns. So for the strategy patterns, we use it in two main areas. The tax calculation, we have different ways to compute tax, and the sorting loads, we also have different way to order the list of loads. So the basic concept of the strategy patterns is to define a common interface for a family of algorithms and let the caller pick which algorithm to use. So instead of writing a big if else change or switch statements to pick the behavior, we can create an interface describing the behavior, then implement one class per behavior, or and use a little resolver or configuration to choose which strategy to use as runtime. So now I am going to walk through the strategy patterns using the new feature updates, the load sortings. So we will see how strategy patterns help with different sorting categories. So on the loads dashboard, user can sort loads in different ways. Sorting by customer name, rate amount, ascending or descending orders, sort by pickup date or delivery date. So a naive way to implement this in load service would be to grab all the loads from the database and use a giant if else or switch block to resolve the short request from the UIs, but this approach would be very messy because the load server would know too much information about the individual sorting rules because we might have to hard coding the sorting logics inside it. Um, uh, and adding new sort option means we have to edit the same big method again. And this also violates clean code ideas like the single responsibility or smart functions. Let's see how we can um, apply strategy patterns with load sortings. So here's the core interface. Load sort strategies. There's two things to notice. Here's the name functions. This is to this is will return string keys like customer name ascending or raise amount descending is like a string key to different sort strategies. And then we have a sort function. Um, this is the actual sorting behavior. It takes in a list of load objects and return new sorting list. Any new sorting strategy we create must implement this interface, and that will give us a unified way to say sort these rows somehow. Now let's look at a few concrete implementations. We have customer name sort strategies, which implement the interface load sort strategies. In this class, it's declare its keys and customer name args. Uh, this would tie to the short parameter used in the URL, and we also have an overridden short function to short loads by customer name. So all the customer name specific sorting logics is contained in this one class. Let's look at another strategies. So the rate amount are short strategy. Again, this class also implement low short strategies, but having different string keys and sorting behavior. So, and if we want a setting order for the rate amount instead, we can use a separate strategy with the same implementation logic. Similarly, we have delivery date strategies. Here we sort by delivery date rules. Again, the important thing is each short rule is in its own small focus class. So now the question is who actually decide which sorting strategy to use based on the query parameter. That is the role of load sort strategy resolver. Here's what it does. So we inject a list of available strategies that implement load sort strategy into the constructor, and then when the controller or load service call sort, we will look up the strategy by keys and then fall back into a default strategy if the key is missing or invalid, and then we will call the appropriate strategy sort methods. So this way, the load server doesn't need a big if or else for each short type. So it just add a resolver to handle it. So here's how load service and load controller use the strategies. So in load service, so it gets all loads from the repository, converts them into load objects and delegates the sorting to the resolver. So it doesn't know how the sorting works. It just know that it can ask the resolver to do it to do it. And here's the flow of sorting feature in load controller. Um, So the browser will send the sort request with a short key contained in the URL, and the controller passes the short key to the load service here, called list load sorted. The load server get all loads from the controller and call short resolver to find the correct load strategy and use it to sort the list. And then the shorted list is converted into the load row object and renders in the UIs. So the reason why we use strategies for sorting is to have a single responsibility. So each strategy class defines exactly one sorting behavior. It is easy to add new shorts, and we can perform clean tests, as we can unit test each strategy class independently, and we can also keep the load service small and readable. Finally, we also use the strategy patterns for the tag calculations. In the building module, we have tag strategy interface with a compute text method and name for the tag strategies. And we also have concrete strategy like pi state tag strategy, flat rate tag strategy, and no tag strategies, and also a tag strategy resolver that decide um, with tag strategy to apply based on the invoice state or configuration. So it's the same ideas as the sorting strategy that we have. One interface, multiple implementation, and a resolver that choose the right implementation at runtime. So the tag strategies are just the same patterns applied to a different business problem. Next, let's look at the adapter patterns in our payment subsystem. So in this tracking app, invoices can be paid using different payment methods, um, like charging a credit card, HCA through a bank transfer, cash, and check like through a simple offline payment. So each of these can work very differently under the hood. A card payments might call an external provider like Stripe or a mock card API. HCA might use a different banking API with its own request and response format. Cash and checks might not call any external API at all. So if we let payment service talk directly to each of these systems, it would know all the detail of all the providers, and payment service would be full of if-else statement for different payment methods, and it can be very hard to change if we add or we swap provider later. So the adapt adapter patterns solve this by putting a consistent interface in front of all those different systems. So in other words, the adapter patterns is basically make one interface that our app understand and write adapter that translate that interface to whatever the external system need. So now let's go through what option our tracking app support. First, we have an enum supported payment methods, card, HCA, cash, and checks. This is what the rest of the app would see. In the UI, we show this option when paying an invoice. So, and in the controller, we parse a string into a payment method value. Next is the payment gateway. This is our central interface following the adapter design patterns. There are two important points we need to take from this class. Um, the first one is name method. This tell user which payment method this gateway support, like whether it's a card, HAs or cash, or a check payment methods. And then we have chart methods. It is the unified operations. It will take in invoice ID, pay amounts, and reference strings, and it will return a payment receipt with a provider. So basically, it's whatever the underlying provider handle it is what it could be a Stripe or it could be HCA's bank transfer and authorization code or transaction code, and then the payment status to tell whether payment status is accepted or declined, and also a timestamp. This interface is what payment server would interact with. The payment server would doesn't know how or have to care whether the underlying implementation is a card, HGH, or a cash. Um, Now let's look at the three adapters that implement payment gateway and hide provider specific details. Here's the card gateway adapter. This class should adapt the card provider API. So name method will return the card payment methods, and the chart method supposed to translate our genetic data like invoice ID, pay amount, and reference string into whatever the request that the card provider expects. Then it will call the card provider API. We haven't implemented that in our system yet, but we can plug in the provider API in future implementations. And finally, we will wrap the card provider response into a payment receipt. So this is the card adapter. It adapts the external card provider API into our internal payment gateway interface. And similar logic apply to HGA and adapter and card adapters. Here's the HGA adapter with the similar ideas. We define an HGA payment method and also call HGA providers or bank API, and map is respond into a payment receipt. So by implementing the payment subsystem using the adapter patterns, all the payments method specific logics is isolated and focused in its own class, and the rest of the tracking app just get a specific payment receipt within a consistent format. So now um, to pick the right adapter for a payment, we use payment gateway registry to go from a payment method enum to the right adapter instance. So here's what happened in payment gateway registry. We built a map of payment method and payment gateway keys by the payment methods in the constructor. If the method is a card, it's mapped to the card gateway adapter. If the method is an HCH, it's mapped to the HCH adapter. And same goes for the cards or checks. It will map into the cash gateway adapters. And then when the resolved method is called, let's say it's called with a card payment method, we will return a corresponding adapter to the payment service. So this gives us a central place to look up the correct adapter for each payment methods. Finally, let's see how this look to the business logics in payment service. So in pay methods, we validate the pay amount. Then we load the invoice and ensure that it's not fully paid. Then we check the remaining balance. Then moving on to the key points of payments, the payment service use payment gateway registry to select the correct payment adapter, adapter to chart the payment, and will receive a corresponding payment receipt that the API provider at runtime. So the payment service never need to know whether the underlying implementation is a card API, HCA banking API, or just a cash marker. So all those details are hidden inside the adapter classes. Its only job is to let the payment gateway interface decide through a registry. So to sum up the benefits of adapter pattern in our payment subsystem, so the rest of the Choking app has one unified interface for charging the payment. Um, so it will chart through payment gateway chart, and each payment method like card, HA cash has its own adapter class. Changing provider or adding new one is localized. We can just add new adapter class that implement the payment gateway. We make sure the name methods return the correct payment methods, and it will automatically picked up by the payment gateway registry. In payment service, it will stay clean and focus on its own business rules by checking invoice status, summing previous payments, updating invoice status, and saving payment entities. So the testing also easier in adapter patterns, since we can mock payment gateway or payment gateway registry in test and unit test. We can unit test each adapter class separately if needed. So this is a very typical and practical use of adapter patterns. We can normalize different external system behind one simple and internal interface. Now, let's talk about the push buttons in our notification system. So in this app, we send different kinds of notification. For example, when a loss is confirmed, when an invoice is created, or when a payment is received, and we want to send these messages over different channels like email, SMS, or push. Since we have these many permutation of notification events and channel, this would blow up quickly. So every time we add a new event type or a new channel, we would multiply the number of classes. So this cross products explosion of message type and channel is exactly what the bridge pattern is meant to avoid. Here's the bridge concept. The bridge pattern separate into two dimensions that can change independently. The abstractions, in our case, it is what we want to say. It's either load confirms invoice created or payment received. And then the second one is implementations, how the message is actually delivered, either through email, SMS, or push. And then we can bridge them so that any message type can be sent through any channel without needing a separate class for every combinations. Let's go into the implementations. Here we define an interface notification channel with one set methods. It doesn't care whether we're sending an email, SMS, or push notification. It's up to the config implementations. Then we have our first channel, email channel, implements notification channel. Right now we just log. But imagine this is where an actual email API call would go. Email channels know how to send via emails, giving a participant and a message text. Um, Similar concrete classes like push channel and SMS channel also implement the same interface. Now look at the abstraction side, the part that knows what to notify about. Um, Here's we have the notification event abstract base class. A few key points here. The notification event has a reference to a notification channel. This is called the bridge. And it also stores the recipient and the customer reference. And each subclass must implement the build message, which return the message text, and send methods is generic. It's called build message to get the text and delegate to the channel sent in notification channel. So this means that the event decide what the message content is, and the channel decide how that content is delivered. Then we have three notification events: load confirm, payment received, and invoice created. Let's look at the load confirm event. This load confirm event is stemmed from a notification event. This subclass add a field for load IDs, implement build messages about load confirm, and it's reuse the same set method logic from the base class. Similar for payment receipt event, knowing is a payment receipt message which include an invoice IDs, amount and payment method in the text. So it's also rely on the notification event send methods is to actually deliver via the channel, and for the invoice created event is following the same patterns. So that's the abstraction side, the base notification event. Then we have concrete classes, load confirm event, invoice created event, and payment receipt event. So each event knows what to say and hold a notification channel to send through. Then we have channel selection in channel type and channel factory. Here's the channel type class. This is what the UI passed into the backend. And here's the channel factory, giving symbol factories, giving channel type is return new instance of the appropriate notification channels. So now we convert the channel type email into an email channel type SMS into an SMS channel, and so on. So putting it together in notification service, here's the class structure. So notification service contain channel factory. It's contain channel factory object. So what happened here is that, so in send load confirm, we add the channel factory. We add the channel factory for the right channel based on the channel type, either through email, SMS, or push. And then we create load confirm event. We pass in the chosen notification channel, the recipient, the customer reference, and load ID. We then call send and record methods. In this method, it will so in this method, it will build a message, send it via the event, and store a notification entity into the database. So the important line is the event dot send function. This call notification event send, which in turn call channel send in notification channel. So that is the bridge patterns in action. So we have the event abstraction is know how to build a message, and the channel implementation knows how to deliver it, and event holds a reference to a channel and delegates the actual sent. And here's and there are similar method for send invoice created and send payment received that just create event types but follow the same patterns. The last design patterns I want to mention is the singleton patterns, and in this project we use it in a very focused way for generating payment IDs. First, quick definitions. Singleton is a class that is designed so there is only one instance of it in the entire applications. So instead of creating it with new all over the place, you usually call something like payment ID generator get instance. So the idea is to give us the only one and only instant. In our app, the singleton is the payment ID generators. Key point here is the constructor is private, so no one can do new payment ID generator from outside, and there is a single static instance store in instance. So get instant is the only way to get that instant. And next ID is the method that actually generate a new payment ID. How do we use this in the rest of the app? So inside payment service, when we are about to say a new payment, build a new payment records, we do payment ID generator gets instant and next IDs. By doing this, we assign that ID to the payment entities and then save it. So what the benefits of singletons? We want one consistent rule for how payment IDs are generated. And if we ever want to change how payment ID are generated, for example, add a new timestamp or a sequence, we can change it in one place and all payment service call automatically get the new behavior. Next, I will walk through the search load features we added on top of the existing load dashboard. So the goal of the search feature is simple. It's let user search load by load IDs, customer name, and load status, all from a drop-down menus, and to show the search result on a dedicated search result page. So the search request is handled by the search controllers in search load. Here's queues in the text that user typed, like customer ID, customer name, or load status, like deliver. And the fields is tell us what they are searching by, either by load IDs, customer name, or by load status. And the search controller doesn't implement the search itself. It is delegated to the load service. Then it map its load to a load row, view model, and return a load search HTML views. And so the business logic for search lives inside the load service in this method. So the search controller calls load service search load. This method break the search logic into small helper functions, either search by ID, search by customer, and search by status. For example, let's look at a search ID. So we search loads by ID from the load repository, and if found, we map the load entity to domain load. And if not found, we will return an empty list. And there are two other search helper for the search categories, customer name and load status. And if the field is unknown or missing, we will do search across all fields helper functions. So in this method, we will search by we try all the we will try to search by ID, customer, and status, and we combine the result and also remove duplicates. This gives a user a best effort search if the field isn't specified correctly. And to wrap up the demo videos, singleton buttons is demonstrated by payment ID generators, giving us a single centralized ways to generate payment ID across the app. And we went over the new short loads feature together with other buttons like builder for load, adapter for payment gateway, builder bridge for notifications, and strategy for shortening text. This gives the tracking app a structure that is friendly for junior developers to understand, flexible enough to add new features, and allow with clean-code principle like small classes, clear responsibility, and readable logics. Thanks for listening.